God. Oh, I'm gonna throw up.
We found them everywhere.
Whoa, he's big.
And not just on the streets. We even spotted them inside high-end grocery stores and fancy restaurants.
Because one breeding pair can produce thousands of rats in just 1 year.
Scurrying down streets, they're even taking the subway.
Back in 2003, 3 New York firehouses had to evacuate. Not because of fire or gas, but because of rats.
They're everywhere.
Oh my God, look at them all.
Hundreds of them, some as big as cats, had overrun the walls and vents.
That big.
I would say about that size.
After months of failed traps and exterminators, the city finally decided to try a radical solution.
We're gonna have to put him in a coma.
Releasing specially trained animals they called R-killers to take back the streets. What happened next was something months of lab experiments could never have prepared anybody for. The first sign of trouble. A routine cleanup call in Lower Manhattan turned into something else entirely. It wasn't supposed to be anything unusual, just a report of several dead rats in an alley behind a mixed-use building. But there was something else, something rather disturbing. The rats had been found dead all right, but there was another unknown animal lying beside them, one that didn't match anything we already knew. Response teams had expected a stray dog, a raccoon, maybe a possum. Instead, they found a creature that didn't fit any standard classification. It wasn't wild, but it wasn't domestic either. It was smaller than a coyote, but also bigger than a ferret, and built in a way that didn't match any normal anatomy. Its musculature was distributed unlike any natural predator. Its teeth were uniform and blade-sharp designed, not evolved. None of this would have mattered if the animal had been a genetic anomaly. But when the field officers scanned the body, they detected a partial identification code burned into the tissue. The format matched a restricted city pest control project, one that was never supposed to leave the lab, let alone show up dead in an alley. Teams sealed the block, collected the rats, bagged debris, and removed every possible environmental sample. Subtle enough that the public didn't notice, but serious enough that the officers on the ground were instructed not to use open radio channels. But the initial findings were straightforward and alarming. From medical reports, the animal had died recently, estimated under 2 hours, but there was fresh rat tissue in its stomach, presumably from the rats found dead beside it. However, the bite patterns on the dead rats didn't match the measurements documented in the project's design phase. But what was even most shocking was this animal was significantly larger than any approved version of the engineered predators. Growth like that doesn't happen without an environmental driver. More tests made the situation worse. Under UV analysis, the animal's blood vessels showed fluorescent markers used only in synthetic gene editing. That confirmed it wasn't a stray, a mutation, or a one-off escape. It was part of the rat control initiative the city had quietly launched in limited zones. And it was not behaving the way it was supposed to. The program's animals were designed to die within a controlled time window, remain nutritionally dependent on a lab-only compound, and stay confined to assigned micro-areas using embedded tracking. But tracking data for this specimen did not exist. Either its tag had degraded, or it had never been picked up by the system at all. Suddenly, a worst-case scenario became the working assumption. If this one reached Lower Manhattan, others might be moving through the city unchecked. Nothing about the physical condition of the body suggested a simple malfunction or a single failed specimen. The chemical residue on its skin, those traces of industrial runoff, solvents, and household waste, showed it had been moving through drain systems and surface environments long enough to adapt. It wasn't long before it became apparent what was going on. This wasn't a controlled release. This was a system that had slipped out of the city's hands long before anyone realized. But why had New York's authorities been messing around with genetics in the first place to kill something as simple as rats? The reason was a result of a problem previous generations had refused to do anything about. The root problem. It all started in the 18th century, when Norwegian rats, also known as the brown rat, alley rat, or sewer rat, arrived from Europe. They got here the moment the first European ships docked in the 1700s carrying cargo, people, and quietly brown rats. The rats weren't native and they hadn't been invited. In fact, the ships who brought them didn't even know they had rats aboard. But as soon as they reached Manhattan's ports, they didn't hesitate. Here was a city already struggling with sanitation. For the rats, this was paradise. Then the 1800s hit and New York exploded. People poured into the city faster than the infrastructure could handle. Tenements stacked families on top of each other, trash piled in the streets, and sewage flowed through shared pits. On one hand, politicians argued and made empty promises about development, progress, and proper housing. But the rats didn't wait for permits. They simply multiplied. Every overflowing garbage heap and every broken food barrel became a breeding ground. When the sewer system arrived in the mid-1800s, it was supposed to fix the chaos. Ironically, it locked the problem in. Those underground tunnels became a climate-controlled transportation network. Warm, wet, protected, and connected. People got plumbing. The rats got themselves a continent. By the time industrialization hit, New York was feeding millions, including the rats. Warehouses leaked grain, markets spilled produce, and the meatpacking industry created a city-sized buffet. Systems meant to move food efficiently ended up distributing it to both the citizens and the pests living below them. And the real kicker? New York never really switched to sealed garbage bins like other major cities. Unlike other major cities, New York never fully adopted sealed garbage containers, keeping trash and plastic bags on sidewalks. Surprisingly, nobody ever thought this was a bad idea, even though it was exactly the kind of system a rat would design if a rat ran the sanitation department. Every night, the sidewalks turned into open-air feeding stations and the rats kept expanding. Fast forward to today, a city of 8 million people built on some of the oldest infrastructure in America. Steam pipes create warmth underground. 24/7 restaurants leak food waste, and miles of tunnels from subways to sewers, and even electrical ones, provide comfortable breeding grounds for these pests. The weather isn't helping matters either. In New York City, temperatures have increased about 0.3 degrees every decade since the 1950s, according to NOAA climate records. What's worse? They're expected to rise between 2 and nearly 5 degrees on average by the next decade. And the reasons aren't far-fetched. Across the board, cities tend to be hotter than rural or suburban areas because of concrete, tall buildings that limit air circulation and heat-generating activities like driving and running air conditioners that emit heat. And since rats are relatively small mammals, they must regulate their body temperatures. Cold weather would place limits on rats, forcing them to stay sheltered for longer and find more food to maintain internal temperatures. On the other hand, New York's warm weather gave these rats more time to be out and about foraging and breeding. Couple this with the 44,000 tons of waste New York creates daily, and you'll see how it was far too easy for these pests to reach a population of around 3 million, compared to the 8 million inhabitants of New York. It wasn't long before authorities had reached the breaking point. Poison resistance had spiked. Trapping rates were dropping. Sightings were up in every borough. One mother even found a rat in her infant's pram on the way to school. But even worse, reports of rat-linked infections were rising, fast. The most disturbing of them was leptospirosis, which in extreme cases could very likely lead to heart failure and kidney failure. Restaurant inspections had become nearly meaningless, as rats had adapted in real time, learning to avoid human schedules. Previous failures. For years, New Yorkers threw everything they could at these rats. From traps, poison, gas, dogs, contractors, and even cats, there was nothing they didn't try. Each time, the city learned the same lesson: rats don't go down without a war. The Queens firehouse story from 2003 was the perfect example. Long before firefighters were forced to abandon the building, they tried every reasonable method to stop the growing infestation. At first it was the usual routine: traps in every corner, baits near the vents, constant cleanups. In a single night, more than a dozen rats would be caught, and anywhere else that would count as a win. But this was New York, and that number didn't even dent the rat population. The next night, the rats were back, squeezing through the walls, skittering above ceiling tiles, and chewing their way through anything wooden, plastic, or electrical. After nearly a year of this exhausting back and forth, the firefighters brought in a private pest control company. Industrial-grade treatments, professional trapping systems, still nothing. The rats were too numerous, too fast, and too good at avoiding whatever humans threw at them. Only after the firefighters finally evacuated and the entire building was stripped and deep cleaned did the infestation break. Across the city, officials and residents tried more targeted measures too. One idea was to pump carbon monoxide into rat burrows. The theory was simple: fill the tunnels with gas, wipe out the colony, seal the problem. But the results were exactly what lifelong New Yorkers expected: nothing. The rats either escaped or adapted, and the burrows remained just as active. Another group took a more old-school approach: hunting rats with dogs. Trained terriers would chase them through alleys and construction pits. The hunts looked good on camera, but ultimately they didn't make a real difference. Catching one rat at a time meant nothing in the face of millions. Other regions that tried introducing predators like cats to control rats found they often targeted easier prey birds and native wildlife, creating new ecological problems instead of solving the original one. The kamikaze experiment. So New York didn't copy those experiments. Instead, they went for something much riskier: biological hunters they called R-killers. A private research group had pitched something new to the authorities: create a small, genetically engineered predator designed to target only rats and die off naturally once its job was done. No reproduction, no long-term environmental impact, no threat to humans or pets. A contained biological version of poison, alive but controlled. It seemed impossible for New York to lose. There were three things needed desperately: reduced rat numbers, faster results, and zero chemicals in public areas. Early documentation promised the animals couldn't breed, couldn't survive without a synthetic nutrient absent from the environment, and couldn't adapt beyond their design parameters. The pitch was simple: release them. Let them hunt. Let them die off naturally. A closed loop, clean, efficient, modern. In internal memos, the hunter animals were referred to as R-killers, a technical way of saying biological traps. Approval moved quickly. Review committees were given summaries instead of full data sets. Safety assurances were based on short-term lab trials, not long-term field behavior. The sterilization gene was marked as highly stable, even though internal emails, later flagged by investigators, suggested uncertainty about how it would behave outside controlled environments. Yet despite these red flags, deployment began. The city was divided into micro-zones. The idea was to release small batches of predators into rat-heavy pockets and compare results. If everything went well, the project would scale citywide. Within the first few weeks, the city celebrated minor improvements. A handful of neighborhoods reported fewer rat sightings. Some traps stayed empty longer. The pilot looked promising on the surface. But there were some issues. Tracking data showed anomalies immediately: animals surviving longer than expected, specimens wandering beyond assigned zones, unexplained weight gain. Each irregularity was logged as non-critical variance and dismissed. The city wanted results. By the time the first mutated specimen appeared, far larger and more independent than designed, containment was already impossible. When the city first approved the engineered predators, it did so under one critical assumption: the animals were built to be safe. They weren't harmless, yes, but they were predictable. Everything about them, from their biology to behavior and even lifespan, was supposed to be locked down by design. The idea hadn't been to create a new urban species. It was to create a tool that acted alive just long enough to solve one problem, then disappear. The fail-safes that failed. The design had four major fail-safes. The first was a sterile gene barrier. Each of these R-killers carried a modified gene sequence that prevented reproduction. The line was engineered to be self-terminating. Even if two animals interacted, breeding was biologically impossible. This was the fundamental guarantee that convinced the city the release was low risk. The next failsafe was the issue of synthetic nutrient dependency. The animals had been programmed to require a nutrient compound only available in the lab. Without it, they would starve. The compound wasn't present in soil, food waste, animals, sewage, or water systems. According to the documentation provided to New York's authorities, this alone made long-term survival functionally impossible. The third was their sensory lock. These R-killers had had the entirety of their sensory system, smell, heat detection, neural targeting, attuned to a single prey signature. Rattus norvegicus's, the brown sewer rats terrorizing the city. Those were the only animals they would seek out to attack. They weren't supposed to chase birds, cats, squirrels, or anything else. The designers called this a chemical selector, ensuring the predators had no reason to attack species outside their target. And finally, there were environmental limits. The animals had been stress tested in high heat, cold, and chemical exposure. The results of those tests showed that their tolerance thresholds were low. They wouldn't be able to withstand the temperature swings of subway tunnels, the ammonia in garbage sites, or the chemical load in NYC sewage. The environment was supposed to kill them long before they reached any other borough. Those were the rules the city relied on, the ones that made them feel comfortable enough to release these animals into the city. The fail-safes were tested in controlled lab environments that couldn't replicate actual NYC. Microplastic concentrations, industrial solvents, pharmaceutical residue, antibiotic runoff. Once deployed, the synthetic nutrient dependency broke down. The sterile genes didn't hold. Environmental limits proved too conservative. The predators lived longer, grew larger, and adapted faster than any model predicted. A tracking signal showed one specimen wandering outside its assigned microzone. Another gained slightly more mass than expected. These were all small quirks, and they were all marked as non-critical variants and ignored. The assumption was always the same. Even if something went wrong, the fail-safes would collapse the system before it spread. But in reality, the fail-safes weren't collapsing. They were being bypassed. The synthetic nutrient dependency wasn't functioning the way the models predicted. The sterile gene barrier wasn't holding perfectly. The environmental limits were far too conservative. The predators were living longer, adapting faster, and interacting with urban chemicals in ways the designers hadn't even considered. Nothing about their behavior matched the intended endpoints. They weren't dying off, they weren't starving, and they weren't staying within their assigned zones. But nobody was saying anything until that fateful day when they found the dead rats with one of the R-killers in an alley. At first, officials from the research group wouldn't say a word about it, not even to the authorities who'd hired them. But then, as days passed and the secret became too heavy to hold, the news began to filter out. Suddenly, multiple researchers from the group began to hand in resignation letters. They wanted nothing to do with the project anymore. For New York's leaders, the problem was less black and white and much more political. They couldn't just step down from office. A decision had to be made. Should they suddenly halt the program and admit defeat to the general public? Or were they to just carry on in silence in hopes that this unforeseen problem would somehow sort itself? While they deliberated, independent researchers noticed. And when they started asking questions, the information wall authorities had quietly built around the city started to crumble. Internal discussions started shifting from scientific control to information control. There was less focus on fixing the problem and more about managing the narrative. Finally, a meeting was held, a quiet consensus was reached. There was no way the city could eliminate the animals without extreme measures, and extreme measures carried risks of their own. The predators were no longer a controllable project, but they weren't an immediate threat either. Removing them might destabilize what little balance existed now. So the official policy became unstated but simple. Monitor, don't disturb, and hope the ecosystem reaches an equilibrium. There was an admission they'd made a mistake, but what had emerged wasn't a monster or an invasive species. It was something far more ordinary, yet unsettling. New York now has a new urban organism. It had been born accidentally, yet maintained naturally. And now it's integrated into the city in a way that made its removal nearly impossible. Sure, it isn't attacking humans or surfacing in daylight, but it's there. Silent, and for now, no one, not the labs or the authorities, can confidently say what'll happen next.